Assalamualaikum. Alright guys, now we continue week 10 for topic 3, shear strength of soil. Alright guys, now we continue week 10, topic 3, shear strength of soil. Here, the program outcomes, PO1 and PO2. Our course outcomes, CO1, CO2, and CO-PO mapping, CO1, PO1, and CO2, PO2. Learning outcomes. At the end of this lecture, students should be able to understand the procedure and determine the shear strength parameters for triaxial test using UU, unconsolidated undrained test, CU, consolidated undrained test, CD, consolidated drain test, and last one, unconfined compression test, which is UCT. And number 2, understand the derivation of failure envelope based on effective and total stress analysis. Remember, based on effective and total stress analysis. First, we go for the triaxial test. Okay, triaxial test is the most reliable method available to determine the shear strength parameters. Okay, so firstly what we are going to do is we have to prepare the soil specimen. Okay, the soil specimen about 38 mm in diameter and 76 mm long in height. Okay, this is generally used specimen dimension. Alright, the specimen is encased by a thin rubber membrane and placed inside a plastic cylindrical chamber that usually filled with water. Okay, when we're talking about filled with water, you should know that it is of course it related to pore water pressure. Alright, and then porous discs are placed at the bottom and at the top of the specimen. The saturated specimen is subjected to confining pressure by compression of the fluid in the chamber. Okay, so we have the confining pressure, okay, or we call it as the sigma 3. Alright, sigma 3. Alright, to cause shear failure, one must apply axial stress through a vertical loading ramp. Okay, must apply the axial stress to the vertical loading ramp. So means that we apply here the stress. Pore pressure generated inside the specimen during test may be measured by means of pressure transducer. Alright, so you may look at this link and refer this link. Okay. Okay, so firstly what we are going to do is we have to prepare the sample. This one is the sample preparation kits. We have the membrane, rubber membrane, and we have the O-ring, and then this one is porous disc, and then all of the transducer and so on. Alright, so what we are going to do is we are placing our sample in the rubber here, and then we will place the porous disc at the top and the bottom, and also the O-ring, rubber O-ring. Alright, so after that we will place the sample in here, and then we will apply the load cell, and then we apply the axial displacement at the top. We will give the force for the normal force here, and then we're going to have water inside the cell, and then of course we will have the sigma 3 because of the stress. Okay, so the cell pressure. Alright, so and then here is the pressure transducer, and this one is pressure transducer also. This one is to determine the pore pressure, and this one is pressure transducer to determine the cell pressure, which is sigma 3. And then we have the axial displacement to determine the axial pressure, or sigma 1. Alright, this is the apparatus for sample preparation. Alright, so this one is specimen preparation for undisturbed sample. So means that we take the sample from the side, and then what we do is we edges of the sample are carefully trimmed. So we trim the edges of the sample and then setting up the sample in the triazer cell here, and then we cover with the rubber membrane. Right, so and then we seal. Okay, at the bottom you see here, this one is o-ring. Okay, this one is o-ring. Cell is completely filled with water. So first is you place the sample here, and then you apply the azier load. Okay, but this actually is not applied directly. We just place the transducer at the top. Okay, and then cell is completely filled with water. We will insert the cell with the water, and then after that, after the cell filled with water, fully filled with water, we will start our test. Okay. Alright, guys, look at this. This one is how the process of the triazer test. Okay, this is the schematic diagram. Alright, so the orange color, this one is your soil sample, and then you determine the value. Okay, you will have the value length and diameter, and then you have the load cell here. The load cell is using to apply the azier load. Okay, so you apply the azier load at the top, alright, to the sample, and then also here we have water. So in the water we will have the cell pressure. Alright, so we have the cell pressure here. Alright, so we have the azier load, azier pressure, and also cell pressure. Alright, if you see here, this one here we have the cell pressure. How to determine the cell pressure, the pore pressure, drainage valve. Okay, it's depend if you want to make it with drainage or without drainage. Okay, saturated or not saturated. Okay, this one is to determine the volume change, and then this one is back pressure. All right, and then we determine the azier displacement here. Right, the stages in conducting triazer test. First, if we have the sample preparation, a cylindrical sample with ratio of size, diameter, height. Okay, diameter to height is 1 to 2. Okay, saturation stage. Okay, B is equal to U divided by sigma 3. Okay, okay, this one is for the consolidation stage. Okay, this one is for shearing stage. Okay. Okay, you have to refer to the stage here. Okay, stages in conducting triazer test. Alright, guys, during consolidation under all around cell pressure. So meaning that, okay, so for example here you have the water. Okay, here is filled with water. So filled with water, we have the pressure from the cell pressure. So cell pressure is sigma 3, and then we apply the azier load. So this one we call as the diameter stress, sigma D. So if you notice here, we have the sigma 3, sigma 3, sigma 3, and sigma 3, and then at the top we have the sigma D. So means that, okay, means that at the top is sigma 1. Sigma 1 is equal to sigma 3 plus sigma D. Sigma deviation. Sigma 3 is cell pressure. Sigma D is diameter stress or azier stress. Alright. So at the horizontal, we only have the sigma 3. Alright. Alright guys, look at this. This is the mode of shear failure in a triazer test. We have the brittle shear failure here. First one. Alright, brittle shear failure. Okay, so we look at this. This one is shear happening, and this one number 2 is partial shear failure. Okay, we have the partial shear. Okay, this one is fully shear, brittle shear failure. And the last one, C, is plastic yielding failure. Okay, what happened is the sample is yield. Right, okay, it's not it don't have the shear, but it's yield, so that's why we call it plastic yielding failure. Alright, for triaxial test, okay, we have 3 types of triaxial test. First is unconsolidated undrained test, or we call as UU. Second is consolidated drain test, CD. And the last one is consolidated undrained test. So we have drain, undrained. Okay, so what is all about? Alright guys, now we go for the difference between types of triaxial tests. Okay, first is we look at the consolidation state. This one is before we start the test. Okay, we consolidate or not. Okay, it's depend on the drainage valve. Okay, so second is shearing stage. Shearing stage. Okay, when we start the test. Okay, time. Okay, the time taken to do the test and the parameters. Okay, and then the application. All right, so look at the first one is UU test. Okay, for consolidation state, drainage valve is closed, so pore pressure, and then pore pressure is generated. Okay, for this one is drainage. For shearing stage, the drainage valve closed, so and then the pore pressure is generated, so means that we have the pore pressure. Okay, this one is very quick test. Okay, okay, so very quick test. This one is application for short-term analysis. So the parameters taken from the test is you're going to have the CU and also VU, angle of friction. All right, so for CU, okay, we go for the CU. Drainage valve open for consolidation stage, but there are no excess pore water pressure. And shearing stage, drainage valve close. When the shearing stage, we close the drainage valve and pore pressure is generated. The test is faster than CD. Okay, slow than UU test. Okay, the parameters we get is CU and VU. Okay, CU and VU, and or C prime and phi prime. So we have the total stress and also effective stress. Okay, this one is for short and long term analysis. And now we go for the CD. Okay, CD is drainage valve is open during the consolidation stage. Okay, no excess pore water pressure allowed. And then during the shearing stage, drainage valve open, no excess pore water pressure. This is very slow test. Okay, so we will get the sigma prime and phi prime. Alright, so this one is for long-term analysis. Okay, when we have the different tests, so you know that the application, this one is for short term, this one is for short term or long term, or this one is for long term analysis, so means that this is for long term infrastructure or structure. Okay. Alright, student, now we go for some practical application of UU analysis for clay. Okay, the application of the UU test we can use for the environment constructed rapidly over a soil clay deposit. Okay, so we have the soft clay here. So this one is embankment. Okay, constructed rapidly. And number 2 is large dam constructed rapidly with no change in water content of soft clay. Okay, this is the 2 application. This one is earth dam. Okay, alright, this one is for embankment. Okay, usually for road construction. Alright, so application number 3 is footing placed rapidly on clay deposit. Okay, so UU test stimulate the short-term condition in the field. The CU can be used to analyze the short-term behavior of soil. So this one is mainly for short and quick tests. Alright, this is UU test failure envelope, total stress failure envelope from the undrained test on fully saturated clay. Alright, so look at this. So this is how the more circle, okay, more circle here. This one shear stress versus normal stress. Okay, shear stress versus normal stress. Okay, first we have the sigma 3 and sigma 1. Sigma 3 and sigma 1, sigma 3 and sigma 1. Okay, this one is, for example, okay, we have the confining pressure, cell pressure 100 kilopascal, 200 kilopascal, 300 kilopascal. Okay, so the total stress is here. Okay, you see here, this is the failure envelope, phi is equal to 0, and then you have the CU only. Alright. Alright guys, now we go for this practical application of CU analysis for clay. Similar to the UU, this one is embankment constructed rapidly over the soil deposit, rapid drawn down behind a dam. This is another one, rapid construction of embankment on natural slopes. Okay, we see here. Okay, note, total stress parameter from CU test is CU and FU can be used for stability program where soil have become fully consolidated and not at equilibrium with the existing stress state. Then, for some reason, additional stress are applied quickly with no drainage occurring. Okay. Alright, so this one is CU test failure envelope. Okay, for CU, you have to know that we can draw two graph paper, two more circle. Okay, so first is total stress. Okay, so for total stress here, okay, we have for example here we have two. Okay, so means that cell pressure for example 100 kilopascal. 200 kilopascal for cell pressure, and then you will determine the value of total stress. For total stress is total, so means that you not deduct with the pore pressure. Okay, for total stress here, for example, total stress failure envelope, you will get the phi here and C. Okay, the value of phi and also C. And then this one is effective stress failure, so you will get the stress prime and stress effective and phi effective. Alright, so this one is angle of friction prime. Alright. Alright, so this one is sigma 3 and sigma 3. Alright, so this one is actually how to determine the U value. Okay, we have the sigma 3 prime and sigma D. So to get the value of U, sigma 3 prime minus U is equal to alright, so sigma 3, okay, this one dah. Sigma, okay, fine. Sigma is equal to sigma prime is equal to sigma minus U. Okay, so means that sigma 3 minus U is equal to sigma 3 prime. So U is equal to sigma minus sigma prime. Alright, so you have here sigma here minus sigma 3 minus sigma 3 prime, you will get U. Alright, so or sigma 1 minus sigma 1 prime, you will get the value of pore pressure. Okay, so for CU, as explained before, you will get the normal stress. Okay, this one is for normal stress analysis for more circle. Okay, and then you will get the value of CU and phi. And then you have the effective stress value envelope. So similar, you will get the phi prime and also C prime. Okay, so alright, so look at this. This one is shear stress versus shear stress versus shear strength. Okay, alright. So this one is actually sigma. Alright. Now we look at some practical application of CD analysis for clay. Okay, first embankment constructed very slowly in layers over a clay soft clay deposit. Okay, this one is them with steady state seepage, and we have the excavation or natural slope in clay. Okay, CD tests stimulate the long-term condition in the field. Those C and Phi should be used to evaluate the long-term behavior of soil. Alright guys, this one is effective stress failure envelope from drain test on sand or normally consolidated clay. So for effective stress failure envelope, so as usual, we will have the shear stress versus normal stress. Okay, so you will get the sigma D and sigma 1. Okay, so you have to know that for this one, effective stress, we determine the effective stress. So sigma 3 is equal to sigma 1 prime. Sigma 3 is equal to sigma 3 prime. Sigma 1 is equal to sigma 1 prime. So you will get the effective stress failure envelope. Okay, so you have know that this one is for CD is effective stress failure envelope. Okay. Okay, look at this effective stress failure envelope from drain test on over consolidated clay. For over consolidated clay, the C maybe will be greater than 0. Okay, and then you have the phi angle. For normally consolidated clay, you will have the cohesion value, but maybe the angle of friction approximately at 0 degrees Celsius. Alright guys, we look at these three cases. Okay, enumerate the types of laboratory triaxial tests you would specify to be carried out in connection with the following field problem. Okay, for the first problem, the stability of the clay foundation of an amendment, the rate of construction being such that some consolidation of clay occur. Right, so this condition we have the consolidation. Okay, so the consolidated undrained triaxial test with pore water pressure measurement would be appropriate for this case. Okay. Right, so for second case is initial stability of footing on saturated clay. So this one is initial stability. So actually the word initial stability for saturated, this one is obvious. This one is of course UU test. Okay, a footing on saturated clay will initially increase with the pore water pressure of the clay. Okay, as consolidation occur, will the effective stresses increase. The appropriate test is UU test. Okay, so for the last one is the long-term stability of slope in stiff fissures clay. So since this one is long-term stability, of course this one is for consolidated drain test. Okay, but what is the explanation? Okay, the long-term stability of slope in stiff fissures clay would depend on the effect of consolidation and water seepage. So CD is suitable. Okay, will give the necessary information about the long-term shearing resistance of the clay. Okay, what is the advantages of using triaxial test? First, specimens are subjected to uniform stresses and strain, right? The complete strength behavior can be investigated. Drain and undrained test can be performed. Okay, if you compare to the shear test, okay, so it's different. Pore water pressure can be measured in undrained test. Okay, different combination of confining and axial stress can be applied. Okay, so okay, disadvantages of using triaxial. Okay, first is triaxial apparatus is so expensive. For the drain test, the test can take longer period as compared to the shear test. Okay, specimen consolidation in the triaxial test is isotropic, whereas the field, the consolidation is generally anisotropic. So this is the disadvantages. So what is isotropic and anisotropic? So isotropic is referred to the properties of a material which is independent of the direction. The anisotropic is direction dependent. So this is the difference between isotropic and anisotropic. Okay. Okay, refer to the exercise. The following result were obtained from the undrained triaxial compression test on 3 specimens of undisturbed sample of soil. Okay, first is cell pressure. Okay, we have cell pressure is 150, 300 and 450. This one we decide. Okay, we decide how much is the cell pressure. Maybe 100, 200, 300. Okay, this one for this question we set as 150, 300 and 450. We set. Okay, ultimate derivative stress. Ultimate derivative stress is the axial stress that we apply at the top. Okay, normal stress. Okay, this one is after failure we get 180, 380 and 550. So ultimate pore pressure. Okay, this one is take from the test. So you get 70, 140 and 200. So first is to determine the total and effective stress parameters. So what is the difference? For the total stress means that you will take the sigma 1 and sigma 3. Okay, sigma 1 is sigma 1, okay, you have to remember that this one is your sigma 3, sigma 3, sigma 3, sigma 3, sigma 3. This one is sigma 3, sigma 3, sigma 3, sigma 3. This one is confining pressure or cell pressure. Alright, so and then we have stress here. This one is derivative stress, sigma d. So means that this one is also, we have sigma d. So means that here we have, this one is sigma 1. So means that sigma 1, okay, for total, sigma 1 is sigma 1, sigma 3 is sigma 3 for total, okay, total. For effective, so you have to determine the sigma 1 prime and sigma 3 prime, sigma 3 prime. Alright, so meaning that you have to determine the value of sigma prime, sigma 1 prime is equal to sigma minus u. Okay, okay, for effective. Alright, so now how to determine the value of sigma 1? Sigma 1 is equal to, sigma 1 is equal to sigma 3 plus sigma d. Alright, so sigma 1 prime, sigma 1 prime is equal to sigma 1 minus u. Alright, so first is what you are going to do is you have to calculate, determine of value sigma 1, sigma 3, sigma 1 prime and sigma 3 prime. And then second is another specimen of same soil field at elevated stress 450 kilopascal. What was the ultimate pore pressure? So you had to determine the pore pressure. So how to determine the pore pressure? U is equal to sigma 1 minus sigma 1 prime. Okay, so that is how to determine the U value. Alright, so in drain test, the pore pressure was 120 kilopascal when the cell pressure was maintained at 250 kilopascal. Determine the ultimate elevated stress. This one you have to determine the sigma d. Okay, so sigma d is how to determine the sigma d. Alright, and then in undrained test, okay, sigma 3, how to determine sigma d is equal to sigma 1 minus sigma 3. Okay, so that one is sigma d. Alright, so in undrained test, determine the value would be indicated for the undrained shear strength in an unconfined compression test. So we will go one by. Alright, so first we will refer to this for total stress. So means this one is undrained. For total stress is undrained. So you determine the sigma 3, sigma 1 and sigma d, the sigma divided stress. For effective, you determine the value sigma 3 prime, sigma 1 prime and sigma d prime. Okay, sigma d is here. Sigma d is diameter of sigma 1 minus sigma 3. Right? Prime, or sigma 1 minus sigma 3. Okay, like that. Right? Alright, so this is the solution. Okay, so first you have the cell pressure 150, 300 and 450. So means that for total, you just take the value of here. 150, 300 and 450. Alright, so this value is sigma 3 is 150, 300 and 450. Sigma 1 is equal to sigma 3 plus sigma d. Alright, so sigma 3 150 plus 180, so you will get 330. Okay, so for effective drain, so this one is for effective, this one is drain test. Okay, so effective cell pressure, so 150 minus 70, so you will get 80. Effective axial stress 260. How to get that? So we have 330 minus 70, so you will get 260. So you have to calculate the rest calculation. So how to do the total shear strength parameters undrained graph? So make sure graph in landscape horizontal position. Alright, this is the data that you have for the total undrained test, cell pressure and axial stress, sigma 3 and sigma 1. Okay, you are going to use this information to draw the Mohr circle. Alright, first step is based on the value of sigma 3 and sigma 1 in the table, determine the scale of x and y axis. And make sure that the x and y axis are the same for the scale. The scale, look at this one is 2 cm is equal to 100. So means that 1 cm is equal to 50 kilopascal. So same thing for x axis and y axis. Okay. Alright, so for the first Mohr circle mark the sigma 3 and sigma 1 in the x-axis. So we have sigma 350 and sigma 1 is 330. So we mark the location, and then what we are going to do is we have to find the centroid. So this is first you place the needle at the compass at sigma 3. Okay, so you will get this one, and then you place another one, place the needle or compass at sigma 1. So you will get the centroid. Okay, now you get the centroid. So what we are going to do next? So we draw a vertical dash line here. So from this one is centroid. So second is, and next is you have to place the needle of compass at the intersection of the vertical dash line with x-axis. Then place the pencil at sigma 3. This one actually you want to draw the circle. Okay, so this one is the radius. Okay, this one is radius also. Alright, so alright, rotate the pencil. Then first more circle will be obtained. So you will get the first more circle. Alright. So and next step is you have to draw the second more circle. You have to do the same step. Okay. The same procedure and the same step. You find the value of sigma 1, sigma 3, plot, and then get the location of centroid and draw the more circle. Okay, now you have the second more circle, and then you do the same step for third more circle. Alright guys, look at this. This one you have 1, 2, 3 more circle, and the last step is using a ruler, draw envelope tangent for all more circles. So you have to draw the tangent for all more circle. Okay, how to draw the tangent? If one of the tangent is untouchable, so you just select the highermost circle. Okay, make sure the tangent does not enter the most circle. Alright, so based on the tangent, the value of cohesion will be obtained on the y-axis. This one is 15 kilopascal, right? Okay, so using the proctor, measure the angle of tangent. Okay, we will get the angle of friction here. Okay, the angle. Okay, so you will get the angle C and also phi. Okay, this is the shear strength parameters for total stress. Okay, so but you have to remember that you have to put here. Okay, this one is shear stress kilopascal, and this one is normal stress in kilopascal. This one is very important. Alright, so now we go for the effective stress parameter. Okay, so make sure the same thing for the normal stress. You have to make sure that the graph in the landscape. So you refer to the effective stress information, sigma 1 prime and also sigma 3 prime. Okay, same thing, you repeat the procedure number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same procedure. Okay, and then after that you will get the value of C and also value of angle of friction here, phi. Okay, but this one is C prime and phi prime. So similar, this one is shear stress and this one is normal stress. Okay, so effective stress parameter, okay, C is 30 kilopascal and phi is 30 degree, right? Okay. Okay, if another specimen of same soil field at elevated stress 450 kilopascal, what is the ultimate pore pressure? Okay, the elevated stress is sigma d 450 given, so you have to determine the u. So this one sigma d is equal to radius. So diameter. So radius is diameter over 2. So this one is our radius. So we have two information. First, okay, we have diameter. Okay, this one is we have the sigma d, and then we have the sigma d is 450. Then okay, this one is sigma 1 and sigma 3. So you want to know the value of u. So sigma prime is equal to sigma minus u. So you want to determine the u. U is equal to sigma minus sigma prime. Okay, sigma 1, contoh lah. This one example. So what you going to do? So first we go for the total undrained test graph. Okay, so first you know that phi is 20 degrees Celsius. Oh my god, it's not degrees Celsius, 20 degree, and then C is 15. So you draw. You can draw the on the same graph, but this one is example, so you draw another graph. So you draw 15 and 20 degree. Alright. Alright, so first is you have the the graph for the normal stress, we have the angle of friction and cohesion, and then you have the radius 225. Okay, so this one, so the length of 225 is 4.5 meter. So what you're going to do is you have to between the envelope line and adjust the ruler to obtain the length horizontal line 4.5 centimeter. Make sure the angle is 90 degree at the top. So this one is 90 degree. So you will get the value here. Draw a line of 4.5 meter. This one is 4.5 meter. So you will get this one 600. This one is this one is actually the center. Okay. Okay, after you get the center of the circle, so 600, so radius is 4.5. So what you're going to do is you have to draw the circle. So you will get the circle here. Okay, sigma 3 and also sigma 1. So from the circle, sigma 3 and sigma 1 obtained as this one. So you will get the sigma 1 and also sigma 3 here. Okay, this one is sigma. This one is sigma. Alright. Alright, for effective strain, actually this one is similar with the normal stress. Okay, so you repeat the procedure number 1, number 2, number 3, number 4, but you are using the information from the effective stress. Okay, for C and also phi. So you repeat the procedure until you get the value 4.5 centimeter, right? Alright. Okay, this is the next step. The last one, you will get the value of sigma 3 and also sigma 1. Okay, this one is for effective. So for ultimate pore pressure, how to determine? Okay, so means that sigma 1 and sigma 3, we get 380 and 820 for total, and for effective we have 170 sigma 3 prime and sigma 1 prime 610 kilopascal. So U is sigma 3 minus sigma 3 prime, so you will get 210, or sigma 1 minus sigma 1 prime, you will get 210. In drain test, the pore pressure was 120 kilopascal when the cell pressure was maintained at 250 kilopascal. Determine the ultimate effective stress. Okay, so first, sigma 3 minus U is 250 minus 120. Okay, so you will get the sigma 3 prime 130. So you have to determine the alpha. The alpha is 45 plus phi prime over 2. So you will get phi prime for effective with 30. So you will get 60. Okay, 60 degree. Okay, next step is you are using the same information from the effective stress envelope. You get if you remember, you have the sigma prime 30, angle of friction prime is 30. So, and then you have to plot the sigma 3 prime. We calculate just now 130 here. Next, we did measure the alpha 60 degree at sigma 3. So this one is alpha 60 degree here from the sigma 3 prime. Next step, you want to find the center. So from the sigma 3 prime 130, place the needle of the compass, rotate the pencil to the top. Okay, rotate the pencil to the bottom. And then you place the needle here, and then you will get the cross. You will get the you have to cross this one to get the center. Alright, next you draw the dash line and then place the needle of compass at the intercept. Okay, intercept of the intersection, then place pencil at sigma 3 prime, rotate the pencil to the right. So sigma 3 here, and then you have the right here. So what you're going to do is you have to draw. Okay, you draw the circle, right? So you draw the circle from here, and then you will get the sigma 1. Okay, so from the Mohr circle obtained, you will get the sigma 1 prime. Okay, sigma 1 prime is equal to sigma 3 plus sigma d. So sigma 1 is 400 90, and then you have the sigma 3 prime 130, so you will get sigma D 360 kilopascal. In undrained test, determine the value that would be indicated for the undrained shear strength in unconfined compression test. Okay, so for unconfined compression test, UCT, sigma 3 is equal to 0. Sigma 3 is equal to 0. So undrained test, total alpha is 45 degree plus phi over 2. So you will get the 55. Alright, so this one is for undrained. So you're using the total stress for undrained. Okay, so you measure the value of C and also phi. Okay, the value of C and phi, and then you draw here, and then sigma 3 is equal to 0. Here, sigma 3 is equal to 0. Sigma 3 is equal to 0. Next step is withdraw the alpha. So from the sigma 3, how much is the alpha? Okay, alpha is 55, so you will get this point. Okay, and then you have to place the needle at sigma 3, and then after that you will get this point. Alright, you repeat the same procedure for this intersection of the line with the envelope line here. Then you will get the cross section here, you will get the center. Okay, place the needle of compass at the intersection of the dashed line with x-axis. So this one is okay. Then place pencil at sigma 3. Alright, sigma 3 prime. Okay, sigma 3 prime here. So this one is center. So okay, then after that you will get the value of sigma 1. Sigma 1 here. Okay, from the center you have sigma 3 and you will get sigma 1. And then this one is UCT. UCT phi is equal to 0. So you look at this graph, circle, you will know that the CU here is horizontal tangent to the circle. So you get the CU is 222 kilopascal. Alright, meter square or kilonewton per meter square. Alright, UCT, unconfined compression test. UCT is a special type of UU test that commonly used for clay specimen. Okay, the surface pressure is equal to 0. And as the load is rapidly applied to the specimen to cause failure. The undrained shear strength is independent of the confining pressure as long as the soil is fully saturated and fully undrained. Alright, this one is the unconfined compression test UCT apparatus. Alright, stress is equal to sigma 1 over 2 is equal to QU over 2 is equal to CU. Okay, so means that CU is equal to sigma 1 over 2 because sigma 3 is 0. Sigma 1 minus sigma 3 divided by 2. So you will get the CU here. Okay guys, now we finish our chapter 3. Remember guys, if you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. Zig Ziglar. Good luck guys.